Hello everyone, the problem that we are going to discuss in this video is iterative pre, post and in-order traversal of a binary tree. So what the question is asking us to do is that we are given a binary tree 50, 25, 12, 37, then on the right side 75, 60 and over here 80. Okay, so we have to print its pre, in and post. So I hope you guys are familiar with the recursive technique, and let's discuss what we used to do when we used to do it recursively. So over there, we used to move first the left side of the tree, then to the right, right? So when we visit the node first time, it is added to the pre. That is, we enter the loop, we enter the call, we move to the left. Now 50 is visited for the first time, so we add 50 to the pre. That is, pre represent that we are moving on to the left side of the tree. When we talk about post, we are moving to the right side of the tree, and in is in between of left and right node. Okay, so let it just start it again. So 50, we are visiting 50 for the first time, we add it to the pre. Okay, now we look for the left of 50, there exists one, we add it to the pre. Now we look for the left of 25 and we add it to 12. If it exists, 12 exists. Now we look for the left of 12. There is nothing. So we come back 12 to a second time, for the second time, right? So we add it to in. Now we look for the right side. There is no right, and we come back to 12 third time. So we add it to post. Now we move back to 25 second time and we add it to the in. And then we look for the right side. There exists a right side, and now this right side we are visiting for the first time, right? So we add it to the pre. Now we look for the left of 37. There is no left. We come back to 37 twice, so we add it to our in. Now we look for the right side. There is no right side, and we come back to 37 third time. We have visited 37 third time, so we add it to our post. Now we move back to 25. We move back 25 the third time. We have already visited in pre, then in, now the post. Now what would be, where would this 50, what will be done when we reach 50? So 50 has been visited once, it is visited twice, so we'll add it to the in. Now we'll move to the right side of 50. This 75 has been visited the first time, so we'll add it to the pre. Now we'll look for the left. Yes, the left exists, so it is also visited the first time, so we add it to the 60. We add 60 to pre. Now we look for the left. There is no left. We come back to 60, and the 60 is visited twice, so we'll add it to the in. Now we look for the right. There is no right. It is visited third time, so we add it to the post. Now we move back to 75, visited twice. We add 75 to the in and look for the right. There exists a right, and this right has been visited for the first time, so we add 80 to our pre. Now we look for the left of 80. There is no left. We come back to 80 again, add it to our in because it is visited twice. Now we look for the right one. There is no right, so we add it to, and we are visiting 80 the third time, so we add it to the post. Now we are going back to 75 the third time, so we add 75 to our post and then 50. Now the entire work is done. We have printed all of our pre, in and post. So what we are doing is we are moving left, in, and then right, in. So this is how we are traveling the tree. So when we are traveling the left, it is pre. When we are in between, it is in, and coming out. I hope this is clear to you. Okay, so now we have to do the exact same process iteratively. Okay, this is how we do it recursively. Also, the one thing that we did notice here is that when the node is traveled for the first time, it is added to the pre. When the node is traveled for the second time, it is added to the in. And when the node is traveled for the third time, it is added to the post. We'll use this observation while doing this problem iteratively. How? We'll look into it. Okay, so let's draw the tree again. We were working on this tree, right? 50, 25, 12, 37, 75, 60, and 80. And we need to print its pre, in, and post order traversal. So we'll take 3 strings where we'll add the values. Now, since in recursion uses the inbuilt stack, okay, and we are doing it iteratively, so we'll use our own stack, and the type of this stack will be the class pair. Now this class pair will store 2 values, node and visited. Now this visited will keep the track. The node is visited how many number of times. If it is visited 1 number of time, we'll add it to pre. If it is visited for 2 number of times, then we'll add it to in. And if it is visited 3 times, we'll add it to the post. Okay, so initially we are here, we'll add 50 and 1 to our stack, and we'll, since this is visited 1 number of time, we'll add 50 to our pre. Now we'll look to its left. Okay, we'll look to its left. There exists 25, right? So we'll add also. Before adding the next node, once we have added it to the pre, we'll increment its visited. Now the next time it will be visited, it will be the second number of time. Now we'll add 25. It is visited for the first time and we'll add it to the pre. Now we'll look to its left, 12, and we'll add it, and before adding we'll increment the visited pointer. Now we'll add 12, 1. Since it is visited 1 number of time, we'll add 12 here. Now there is no left to the 12. Okay, so, and after looking for its left, we are coming back to 12. That is, we are visiting it for the second time. We'll add it to the in, and we'll increment it pointer to 3. Now we'll look to its right. There is no right. We'll come back to 3, and it has been visited now the third number of times. So we'll add it to our post as well. After adding to our post, its work is done. So we'll pop it out of the stack. Now 25 is visited for the second number of time, right? So we'll add 25 to in. Now we'll increment its counter to 3, and we'll look to its right. There exists a value 37 which is visited for the first time, so we'll add it to the pre, right, and increment its counter to 2. Now we'll look to its left. There is no left, so we'll add it to the, and the point, and the visited is the second number of times, so we'll add 37 here. Now we'll look to its right. There is no value, and 37 is again visited the third number of times, so we'll add it to the post. Now we'll move back. Now here 25 is visited the third number of time, right? Also, this was incremented after we printed it in, and this work is done, so we pop it out. Let me remove it. Okay, so now 25 is being visited third number of time, and we'll add it to our post, and we'll remove it. We'll remove it from the stack. We'll pop it out. Now 50 is being visited second number of time. We'll add it, and we'll increment its counter to 3. Now we'll look to its right. There exists a value which is being visited for the first time, so we'll add it to the pre 75, and we'll increment its counter to 2. Now we'll look to its left. There exists a value. We add it to our stack, visited 1 number of time, add to the pre, and increment the counter to 2. Now we look for its left. It does not exist. We come back to 60, and we see it is visited 2 number of times, so we'll add 60 to our in, and we'll increment the counter to 3. Now we look for right. There is no right. We come to 60 again, and we see that we are visiting it for the third time. So we add it to our post, right? I hope this much part is clear. Now we move back to 75, right? This has been popped out. Now this is being visited for the third time. So we'll add it to our, okay, we are going back to 75 for the second time. Sorry. Okay. After 60 has been visited for the third number of time, 75 was being visited for the second time, right? It was being visited for the second time. So we'll add it to our in and increment its counter to 3. Now we'll look to the right. There is 80 which is being visited for the first time. Add 80 to our pre, increment the counter to 2. Look for the left. There is no left. We come back to 80 for the second time, right? We add it to our in. Okay. Now we look for the right. There is no right. We come to 80 for the third time. This has been incremented. Okay. Now we add this 80 to our post. Now we move back to 75 and we are traveling it for the third time. So we add 75. We pop this out. Now we move back to 50, which is being visited for the third time, and we add it to the post and we pop this also. Now our stack size is 0. Our work is being done. And what we are going to do is we are going to print all of these strings. I hope this thing is clear to you, that we are going to keep which node is being visited how many number of times. Suppose 50. If it is visited for the first time, add it to the pre. When it is being visited for the second time, add it to the in. And when it is being visited for the third time, add it to the post. Now let's just code this problem. Okay, so we will be coding this problem now. Okay, now the pair class has already been written. What we are going to do is we are going to come over here and we are going to make a stack of type pair which store two values, node and the visited part, how many number of time we are visiting it. Okay, is equals to new stack, right? We'll create a new pair is equals to new pair, and we are going to add the node and 1 because we are visiting for the first time, and we are going to push it to the stack. We are going to push this p. Now we'll work until stack.size is greater than 0. What we are going to do is we are going to look for the top. So we'll take the top of the stack, store it in the top variable, and now we'll see if top dot, let me see what the value was, state here, state. So if top dot state is equal 1, we have to do some work, right? Else if the state is top dot state is equal 2, then we were doing adding it to the in part, and else we are doing it the post work. Now also we'll need 3 strings, string pre, sorry, so string pre, string post, and string in. These 3 strings we have. Now if top dot state is 1, we are going to add top dot node dot data to our string, right? And we are going to increment the state by 1, right? The same thing we are going to do here. If the state is 2, then we are going to add it to our in string, that is top dot node dot data and we are going to increment the state. So we are going to do top.state plus plus. Now, if the state is not 1 or 2, it means it is 3. So what we are going to do is we are going to add it to the post. We are going to do top.not.data, and we are going to pop the value out, because after that there is no work we have to do with this particular node. Now, if the state is 1, what we were doing is we were looking at the left side, right? We were looking at the left side of the tree. So what we'll do is we'll look if top.not.left is not equal to null. What we were doing is we are creating a new pair, left pair, let's say, and what we'll write there, we'll do top.not.left with the value 1, because we will be visiting it for the first time, right? And we'll push this st.push, and we are pushing it to this LP to our stack. Now this exact same work we are going to do if the state is 2. The only change that we'll do is we'll look for the right side. That is, if the right side of the top node is not null, then add that right, because that right is also being visited for the first time. So we'll add the state as 1 and we'll push this RP. Now, after coming out of the while loop, what we are going to do is we are going to print this system.out.println pre, and the same exact work is being done for in and post, right? So what we are going to do is in and then post. Let's see if it runs. Okay, I did something wrong. Cannot. Okay, the pair is small. It should be capital. And so here, small mistakes. Let's submit it. Okay, it has to be submitted. Okay, let's try to submit it again and see if it works. Yes, thank you.